try to rotate shape C, this rectangle, 90 degrees anti-clockwise about the center of rotation -5,3 here. So we will first of all make a line from the center of rotation to one of the vertex here. Let's take this one. And just to make it easier, we will try and put a mark there with the red mark here, red dot. Okay. And we will use the protractor now. And the first thing we do, we will put the center of the protractor exactly where the center of the rotation is. And then afterwards, we will align the protractor, the 0, with the line that we have just made between the center of rotation and the vertex we would like to rotate. So clearly now we can see that this line here we are going to move. So anti-clockwise, so this way, this direction for 90 degrees. So more or less here. And then to make it easier later on, we will make a line from that center of rotation similar to what we have here, similar to where the line of 90 degrees rotation is. So this way we can remove the protractor, and then we could see that this line that we made before has been rotated 90 degrees anti-clockwise. So obviously this point later will be located somewhere along the other line. So how do we figure out where exactly? Then we have several ways. We could, for instance, take a ruler and let's say try to measure. Okay, we can try and measure how long the distance is from the center of rotation to the vertex we are rotating, because remember the original vertex distance to the center of rotation should be equal to the distance of its image to the center of rotation. So here it's about like 3.7, 3.8. So then if we do the same here, more or less it will be around 3.7, 3.8. So it's about this point over here. So it's about here, -1,4. So let's put a mark there with red as well. So this is the image of the red vertex in the original figure. Another way to see this is by looking at the distance as a rectangle, diagonal of this rectangle. So this diagonal of this rectangle of 1 by 1, 2, 3, 4. So 1 by 4 rectangle. So obviously here the distance from center of rotation and the image, this red image, is also a diagonal of 1 by 4 or 4 by 1 rectangle. So these two diagonals must be equal length then, right? So here, this is what I mean. This distance must be equal, and that is the requirement of a rotation. Okay, so one vertex is already clear. Then we can remove all our helping line and signs. So we have this red vertex already rotated there. So we can use another one. We can try and rotate another vertex. Let's say this one on the left bottom corner. We'll just put a blue sign over there. And similarly, we will draw this line here. So crossing the blue vertex and center of rotation. And then again, similarly, we will take the protractor, align the center to the center of the protractor to the center of rotation. And then similarly again, we will align the zero of the protractor with the line that we have made before. And then again, we can rotate it. So this direction counterclockwise to 90 degrees. So here it is. And we will use again helping line for the image, and just by making a line right on top of the one of the protractor that we did just now. So then we can remove it already. And now again, we will try, we can actually measure this distance as well. Again, one more time with our ruler. So this distance from the blue vertex to center of rotation should be equal there. And again, similarly, we can use our ruler, or we can do so by counting as a diagonal of a rectangle. So let's try first with the ruler to try this. So if we use our ruler up to the blue vertex is about 9.3 or 9.2, between 9.2 and 9.3. So then if we do the same here, between 9.2 and 9.3 is about this point, at this point 5,1. So let's try that. We will put a sign there, a blue sign, 5,1 here. And then let's see whether it makes sense. So this diagonal to the blue vertex from the center of rotation is a diagonal of a rectangle 2 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 by 10. So let's see here whether we actually have 2 by 10 rectangle or 10 by 2 rectangle as well. So 2 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 by 2 as well. So this must be then the same length as the other segment over there. Okay, so knowing this, we can remove all the helping lines so that it's not too much or too many lines later on. So we already have this red one and the blue one over here. We know that they are across to each other, so we kind of like more or less see that it must be this shape, right? The C apostrophe or the image of the rectangle C must be this shape. However, just to be sure, we will try one more vertex. We will label it as a green vertex here. And one more time, I'm going to make sure that this is the segment that we will draw there. And again, using our protractor, we are going to try and rotate that segment accordingly. So let's try that. We align the 0 to the segment. We rotate 90 degrees, so more or less here. Okay. And again, I'm going to make a line which is on top of this 90 degrees from the protractor. Then we can remove the protractor. And then now this time around, I'm just going to count the rectangle. So this is a diagonal of a rectangle 1, 2 by 1, 2, 3, 4. So 2 by 4. Okay. So then along this line, there is a point where it's going to be again a diagonal of 2 by 4 rectangle. So 2 by 4 rectangle, there is this point over here crossing at exactly the expected place. And again, this is a rotation of 90 degrees angle counterclockwise. So removing everything now, we can see the three colorful vertices, the red one, the blue one, and the green one. Then the only thing we need is actually the last one, of course, but which clearly is going to be here. And the only task we have now is just connecting all the vertices of the image of rectangle C, and we are going to name it C apostrophe. Okay, and don't forget that if we have a rotation of 90 degrees counterclockwise, you will get the same result if the rotation is named 270 degrees clockwise. So if you rotate 90 degrees anti-clockwise, it will be the same as rotating 270 degrees clockwise. Okay, so again repeating, 90 degrees anti-clockwise is the same as 270 clockwise direction. So hopefully this is clear, the method, and you can try the exercises. Good luck!